All right, class, let's continue our talk on trigonometry. And in this section 5.2, we're going to be talking about the unit circle and sine and cosine, what you have learned trig is all about, right? Sines and cosines. Okay, so we're going to talk about that in a minute. So here it is. I already drew an angle theta in standard position. So just as we reviewed in the last section, that simply means its initial side, yes, it's on the positive x-axis, its terminal side is somewhere, it doesn't matter, okay? So, now, what is the sine and the cosine value? I'm going to get you started with a definition you have, or you might have if you took trig on our campus. This was the first definition that you have learned in chapter 1. That fine, here's the angle. All you have to do is draw any circle, and I'm going to draw a circle here. I'm going to make it red. I don't want to make it too big. But you draw any circle around. And again, we kind of saw how the radian measure starts comparing with the degree measure. We need circles, we need angles. We need an xy plane, right? So of course this angle theta could be measured in radians and it could be measured in degrees. If I were to measure it, I probably will find about 45 degrees in measure, and in radians, that might be definitely, well, about less than 1 radian. Again, this radius looks bigger than the arc, it looks bigger than the arc length, right? Okay, anyhow, what did we do? Or what is the first definition that you have learned? That we simply pick a point right here where my random circle connects the terminal side. And that point, of course, being on the xy plane, will have some coordinates xy, right? Now, as I said, I'm picking a circle at random, so it has a radius r at random, okay? Now, we simply define the sine value, and that's all we're going to be talking about in this section, just sines and cosines. We find that the sine value of this angle theta is simply the y-coordinate of this intersection point divided by the radius. And the cosine value of this angle theta is the x-coordinate divided by the radius, okay? So, sure enough, forget what I was going to say. Y over r and x over r are these values. Oh, this is what I wanted to do. Now, sure enough, if I were to draw this right triangle right here, it's a right triangle. If you think about it, where do these x and y coordinates tie into this triangle? Y is the y coordinate. So in other words, it's the height, right? From the x-axis up to this coordinate of y. X is its x-coordinate, so in other words, from here to here, that's a distance x. So what I wanted to show you is, of course, in high school, the first thing you've learned about sines and cosines is that in a right triangle, the sine value of an angle is opposite, so there's y, over the hypotenuse of this triangle, right, which is r. So perfect, our definition. And also the cosine value of this angle is the adjacent side, which is x, divided by the hypotenuse, which is r. So as you see, it's consistent with that definition as well. So we're going to go over that very much simplified definition in section 5.4, okay? Now, the thing is, as I said, I picked a radius, I picked a circle at random of radius that's random. Now, could I have drawn a different circle around? Sure enough, let me find a better color. I could have drawn this circle that's much smaller, right? So sure enough, I'd have different coordinates. I'd have maybe, let's say, an x prime and a y prime coordinate, right? And this would have a different radius, call it r prime. Now the thing is, what is the definition? Well, the sine value of this angle theta would have to be the y coordinate on this new circle, which is y prime, over the radius of this new circle, which is r prime. It's the same angle, right? So it has to have the same sine value. And sure enough, as you see, these are similar triangles. They're proportional, right? Y over this r is equal to this y over this r. These two are similar triangles. Their sides are proportional to each other. Of course, we're going to get the same sine value. So because it doesn't matter what big or how big is this circle that we're choosing, right? The ratios are equal to each other. We might as well make it extremely simplified. And how much simpler can it get? Well, it could get super simple and choose what we call a unit circle. So what is a unit circle? Well, it's simply a circle with radius 1. So because it doesn't matter which circle we're going to pick, we're going to make this super easy. And we're going to pick the circle with radius 1. So it's going to cross at these points of coordinates. It just only goes one up, down, and so on, left and right around the center. Well, not much of a circle. Didn't pick my units correctly. It's kind of hard from where I'm sitting. All right. And then, what did I say? Fine, here's an angle theta in standard position, and it's the same definition that I'm using as up above. They're what? You pick an x and a y, right? Pick the x and y coordinates of this intersection point, and then do what? The sine value of this angle theta is equal to what? Y over r, but because we chose a unit circle, what's the radius for us? Well, it's 1, right? So it's just y for this specific, right? This is a 1 measure, 1 unit radius. And then cosine of theta is then simplified to what? X over r, which is, by the way, 1. And that means just an x. So we don't at all have to deal with this second quantity of r. We just simply pick the y coordinate for the sine value and the x coordinate. But you have to be on the unit circle to do so. If you're not on the unit circle, then, well, the radius is not 1, and then you ain't dividing by 1, you're dividing by something else. So here is our definition. I'm going to write it down. This is the second definition you have learned in your trig classes. Here, I'm going to pick this pen here that says they're what? Given an angle in standard position sine value of this angle, let's say call it theta, okay? So the sine value of this angle theta is going to equal to the y coordinate of the point of intersection between the terminal side of theta and a unit circle, or I should say the unit circle. And it should be clear, it's not just any circle of radius 1. Center also has to be in the origin, right? There's plenty of circles of radius 1 we could draw anywhere on the xy plane, but it's the one with the center in the origin, right? So when I talk about the unit circle, yes, we mean the center in the origin, radius is 1. And sure enough, cosine value of this angle theta is going to equal to, I'm not going to write the same thing, but it's the x coordinate of this point of intersection, blah, 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 blah. So That's all we have to do. Okay. So that's the most simplified definition. Okay. All right. Now, this way we can modify our definition to real numbers. What do I mean? In other words, we shouldn't just be talking about the sine of some angle theta or cosine of some angle theta, but we can very well be talking about sine of some kind of number. And what kind of number do I want? A real number, or cosine of a real number. Because that's ultimately what our goal is. We want to make sine and cosine functions. Right? So our input should not be an angle, it should be a number. Okay? So, how are we going to do that? Well, it's pretty simple. Remember how we didn't even put units on the radian measure? Well, that's it right there. So I'm picking my unit circle right here. Okay, so in other words, the radius is 1. Okay, and this is what I'm going to say. What is, for example, sine of 1? Well, you can see how it doesn't say degree. Sine of 1 really means a sine of what? 1 radian, but radians don't have measure, so you can think about the sine of the number 1 as what? All I have to do is do what? On this unit circle, I'm going to travel from here, and I know already this is a 1 unit, yes, because it's the unit circle, it crosses a 1, and again, you can make your units as large as you want, but all I have to do is go along the circle a distance just as long as this 1. Okay, so if I go a 1 distance away, 1 unit, number 1, then all I have to do is pick this y coordinate. And I'll write it down one more time. Right? So, but that's really the same thing as what? The sine value of an angle of 1 radian. Right? Okay. And then what's going to be cosine of the number 1? The same way, cosine of number 1, from this point here, start traveling 1 unit and choose the x coordinate, okay, of that point you are arriving at. So this point here has coordinates cosine 1, sine 1. Okay, it's 1 unit to travel. Okay, so that way we can define sine, cosine, and the extended other trigonometric functions we're going to talk about in 5.3 of any real number. Okay, so yes, sine of 1 is really the same thing as you see as sine of an angle of measure what? 1 radian. Yes, because this, what is a 1 radian? 1 radian is the angle, right, that subtends an arc of the same length as the radius. So we already know the radius must be 1, yes? So then this arc length here has to be 1 as well. And there you have it. So sine, I'm going to write it down. Sine of any number value x is equal to, and again, why do I have to start at this point? Because that's where the initial side of this angle, right, crosses through the circle. And I have to go till the end, right, to the terminal side of this angle. So sine of x is simply the what? The y coordinate of the point on the unit circle okay, that is to be found by traveling x units, maybe I shouldn't say it again, it's not the same as the coordinate. Fine, I'll call it a t, so we don't confuse the x and the y coordinate. Call it a t. By traveling t units from the point of coordinates 1, 0 along the unit circle to this point. So I'll explain in a bit some more. And then what's the cosine value of some number t? You pick the x coordinate of this point, so on and so on. Okay, so one more time. If I want to find the number, let's say I want to find sine of 3.5. That's a real number, yes? How do I find sine of 3.5? All I have to do is draw myself a unit circle. And here, I'll pick a nice, this should be a 1 unit, right? This is your unit of measure. And I'm going to draw myself the circle, yes? So what is sine of 3.5? From this point right here, from the point of coordinates 1, 0, right? This is the initial side, right? On the positive x-axis and the circle. So from here, I have to travel, that's about how much 1 unit is. So there's 1 unit. There's a second unit. There's a third unit. Right? So this is my unit length, right? 1 of it about, 2, 3, and a half of it. Okay, so in a bit, so 1, 2, 3, and that's 3.5 units, right? So once I arrived here, all I have to do is pick the y coordinate of this point. The y coordinate of this point is sine of 3.5. And I dare you to put this in your calculator, which I'm going to take right now, and put in my calculator sine of 3.5. So I'm going to show you. Clear sine of 3.5. Now, this is crazy because what do you think? Is this 3.5 a degree? Is it a radian? Of course, it's a real number, but your calculator doesn't know that, right? Your calculator has different modes, right? And it's always set to be degrees because mostly that's what we're dealing with. So I'm going to clear this and I'm going to make sure that my calculator is in radian mode. This 3.5 doesn't have a degree symbol to it, does it, right? Plus, 3.5 degrees would be super tiny right here in the first quadrant, right? 3.5 is the same thing as 3.5 radians. Okay, so what is sine of 3.5? And now the calculator knows it's radians. And the answer is negative 0.35. So let's look at it. I have to pick the y coordinate of it. Well, that looks pretty good, right? At about negative 0.35, right? This is negative 1, and yeah, it kind of looks like we're about a third of the way down, right? Below 0. What do you think cosine of 3.5 should be? It's the x coordinate of the same point here, yes? So the x coordinate of it, my prediction based on my graph, right, should be also negative, yes? This is a negative 1 right at the edge. So this, my prediction should be about negative 0.9-ish. So let's see, what's cosine of 3.5? Look at that, negative 0.93 so-and-so, right? So I said it looks definitely like it's closer to the negative 1. So that's all you have to do. Pick the x coordinate, that's your cosine. Pick the y coordinate, that's your sine. Can I find cosine and sine of negative values? Definitely. However, what would be sine of, let's say, negative 2? That simply means from this point of coordinates 1, 0, what do I have to do? Because it's negative, I have to travel in a negative direction. By how much? Negative 2 of these radii. So that's about where negative 1, negative 2 of these radii might be. So it's this point here. So if I put in my calculator sine of negative 2, I'm guessing the answer should be close to a negative 0.9, right? That's very close to the negative 1 coordinate. So what is sine of negative 2? Yep, negative 0.90. And then the cosine value of it is also negative. Both these angles, right, and radian measures happen to be in the third quadrant. So cosine of negative 2, what is our prediction? It's about negative 0.2-ish, negative 0.3-ish. Oh, well, negative 0.4, fine. It's a little bit fine, more towards the middle, but yes. All right, so that's that. So if you have the unit circle, now you get it. I hope so. If you have the unit circle, yes. If this is a unit circle, means what? This is a 1, 1, negative 1, negative 1. So 1 unit long, yes. If you pick any point on this circle, what is the point of this circle going to have? The x coordinate is the cosine value of some number, whatever this t long is, yes. And then the y coordinate is the sine value of this t long, whatever it is, yes? Which, by the way, is the same thing as cosine or sine of this angle theta here that measures t radians. Okay, so there you have it. All right, now that's how you find numbers. What sine of negative 300? Well, start here, go negative 300 of these ones, all until you get super, super dizzy, because there's a lot to go until you got 300 of these units. And then finally, you got somewhere, yes? Let's say whatever point you have. Okay, just grab the y coordinate of that point for the sine value, just grab the x coordinate of that point for the cosine value, right? Just reading the x and y coordinates. Okay, now, what we have, of course, are calculators, but how does your calculator even know to measure? Because mostly what it does is based on special angles. So that's what we'll be talking about. Which special angles are we talking about? Something that we already know how to find. So, super easy. It's going to be the 30, the 45, and the 60-degree angles, okay? And also any quadrantal angle. So in other words, 0 degrees, 90 degrees, and then we're going to extend these values to any other quadrant, and then we'll talk about something called the reference angles. Okay, so easily, let's start with 0. That's easy. What is 0 degrees? This right here, yes. Oh, and by the way, why am I talking about 0 degrees again? Degrees can be transformed in radians, and radians are the same as real numbers, right? So as I said, whether you talk about cosine of 5 or cosine of an angle of 5 radians is the same thing, okay? But it's much easier to look at it in terms of degrees because that's how triangles function. Now, it's super easy to see that what? 0 degrees is right here where you didn't go anywhere. What are the coordinates of these points? 1 and 0. So cosine of 0 degrees is 1. Sine of 0 degrees is 0. Okay. I said we're going to do the same thing for 90. 90 is right up here. Okay. What are the coordinates of this point? Well, 0, 1, right? So cosine of 90 degrees is 0. Sine of 90 degrees is the y coordinate, so that'll be 1. Okay, and then I said we're going to pick some numbers in between, right? 30, 45, and 60. So kind of we need that right triangle trigonometry, in other words, opposites over hypotenuse. to come up with these angles. So I wish we would have started with that definition, but most trick books never do. So here it is. This is an angle that's 45 degrees, yes. So if this is an angle that's 45 degrees, you got yourself the x and the y coordinates are the same, yes. So x is the same thing as x, or y is the same thing as y, because you're going halfway through the first quadrant. So y is the same thing as x. So this is a 1, this is an x, and this is also an x. So out of Pythagoras' theorem, we can do what? X squared plus x squared is equal to 1, right? Again, y is the same thing as x. You're on the y equals to x line, right? Okay. So here is my 2x squared is equal to 1, which means x squared is 1/2, which means x is, when you, please don't forget the plus or minus. Many students do. Okay, it's a quadratic equation. It has two answers. That's the square root property. You take the squared on both sides, you have to put plus or minus to get your two answers. So plus or minus, when you simplify this, that's a square root of 2 over 2. So that simply means cosine of 45 is the same thing as sine of 45 is equal to square root of 2 over 2. Okay, and why is it positive? We're in the first quadrant, right? X is positive in the first quadrant. So even though we get two answers for our problem here, only the positive one makes sense. As you see, you're in the first quadrant, right? So I don't really want to go through the 30, 60, 90 triangle, but fine. I know I cannot not do it. So I'm just going to use that right triangle trigonometry. Where does a 30, 60, 90 triangle come from? From an equilateral triangle. Comes from an equilateral triangle, right? These are all 60 degrees. And none of it is 90. So fine, here is a 90. I'm going to draw the height halfway through. So there is my right triangle. Now this angle here gets cut in half and turns into a 30, 60, 90 triangle. Okay, so to keep things simple, of course we can say this is a 1, but I'm going to make this side 1. So that's 1, that's 2. Yes, that's exactly halfway through, right? This is an isosceles triangle. So if you pick the sides, equilateral triangle. So if you pick the sides, let's say to be 2, just for simplifying reasons, then this one is half. So I'm going to need the value up here, and the value up there is going, let me call it an x or something. So x squared plus 1 squared is equal to 2 squared, right? Just Pythagoras' theorem. So x squared is equal to 3, so that means x is plus minus square root of 3. But because we're going to keep it in the first quadrant, then again, we're going to keep this positive. So again, if you use the right triangle trigonometry you've used, and I know we're not supposed to maybe do that until 5.4, but I also know you've already passed trigonometry coming in here. What is sine of 30 degrees? Is the opposite, which is 1, over the hypotenuse, which is 2. And that's the same thing as cosine of 60 degrees, by the way, because what's cosine of 60 degrees? The adjacent over the hypotenuse. And the same way, sine of 60 degrees, this is here, is the opposite, which we got to be square root of 3, over the hypotenuse, which is 2. And that's the same thing as cosine of 30 degrees. So that's really where they're coming from. I didn't want to make it a big deal because, well, yes, you've learned it. Second of all, yes, we're going to go over it more times. And third of all, you're never going to draw yourself triangles to figure out these values. You will have them memorized. So rather than dwelling on where these numbers come from, I'm going to show you, because you're not going to sit really, but okay, fine, if you don't remember them and have to derive them, that's where they're coming from. But what you're going to simply do is memorize this table of values. So I'm going to write it down for you, okay? So here it is. What are special angles? I make a table of values, and I'm going to show you, rather than how to find them in, is how will you have them memorized. So I'm going to put them here from smallest to largest: 45, 60, and 90. Okay, and for this section, as I said, we're only going to go over sine and cosine. The next are following in the next section. Of course, if you talk about tangent, cotangents, secants, and cosecants, that's what's coming up. So the way to memorize, and again, all those, the way we figured them out, I put them on the previous page. That's not that important. Here it is. What I'm going to do, I'm going to show you the simple way. What you're going to do is fill in the numbers 0, 1, 2, 3, and 4. Okay? And then you're going to take the square roots of all these numbers. And then you're going to divide them all by 2. Which might seem like a lot of things to remember, but it's not. So what is the square root of 0 divided by 2? That's, by the way, is 0. Square root of 1 is 1. Square root of 2 over 2, that's square root of 2 over 2. This cannot be simplified, but what's the square root of 4 over 2? That's a 2 divided by 2 is 1. So if you look back on my previous page, right, where we figured out everything, these are exactly those values. Okay. Now, how do I get the cosines? We'll talk about this, but sine and cosine are co-functions of each other. In other words, cosine of 0 is the same thing as sine of the complement of 0. So numbers that add up to 90, yes? So cosine of 0, which I'm going to fill in here, is the same thing as sine of 90. So all you really do to figure out these answers is reverse the whole table of values we just made. Okay, so these are complementary angles. 30 and 60 are complementary angles, right? And again, if you look back on the previous page, you will find exactly those values. And 45 and 45 are complementary angles to each other. Okay. The other thing I want to do is, these are the exact values. And this is what you have to have memorized. Okay, not only, many times we're going to be dealing with radians, so 0 degrees is 0, or 0 radians. 30 degrees is pi over 6. 45 is pi over 4. 60 is pi over 3, and 90 is pi over 2. Okay, and again, this you should also completely have memorized. So the more practice you are doing, the better it's going to be for you. And hopefully you already know that, because again, you've had to have trig prior to coming to pre-calculus. None of the stuff that we're going to do is new. All of it is review of trig. So all of this stuff you guys should already know. Okay, right, so we're going to take a break for this video. It's gotten long enough, and we're going to continue on the next video.